Hello everyone, welcome to lecture 20. This is the second lecture of module 6, that is on cryosphere hazard. So today we will see more details about the cryospheric hazards. So before we get into the hazard part, let us understand why exactly this glacier study or cryospheric studies are needed, right? So we will start with this, what is the importance of glaciers and the glacier study. So if you see here, glaciers plays a crucial role in ensuring a stable year round water supply. So basically we are dependent on the glacier fed rivers, and some of them are purely glacier fed, some of are rain fed, right? So it is mixed with both. But if you see the year round supply, that is coming from the glacier fed rivers, right? So for example, Gangotri is responsible for Ganga rivers, and the glacier near Lake Mansarovar, that is for the Brahmaputra river. Rapid deglaciation is a potential consequence of evident climate change, because if you see, if there is change in the temperature, pressure, right, any atmospheric components are changing, that is directly impacting the glaciers. And understanding the progenesis of glacier requires knowledge about their mass change. So if you want to see how they will be in future, what will be the status, then you need to have very good understanding on the mass balance, right? So coming back to again this, the importance of these glaciers. So it is basically the year round water supply, that is what we need to sustain on this particular planet. So before we get into the hazard part, again let us see some of the more basic components. So let us see the details of glacier system. So here you can see the ice or the mineral debris that is coming into the glacier system. So what happens, it starts with the solid precipitation, and slowly because of the metamorphism it gets into the glacier ice, and because of the influence of the gravity they start their movement. And during the movement what happens, the rock debris are supplied to this glacier system by erosion from the glacier bed or by rock falls, right, and that is coming into this glacier system here, and slowly they are coming to the zone where it starts melting, right. So the melt water, that will again it will link to the fluvial system which is in the downstream, and that will feed this particular river, and that is coming to our region, right. So output by release and deposition may subsequently be affected directly by glacier ice or indirectly by the action of melt water. So here whatever we see the changes, it is because of the melt water, sediment, and how this glacier system is getting affected by the climate change, right. If you see the glacier and the environment, so here the development of glaciers depends upon the complex interaction of climatological, topographical and geographical factors, of which precipitation and temperature are most important controlling climatic factors, right, because this will decide whether you will have positive mass balance or negative mass balance. For glacier development, high annual precipitation is required in the solid form, that is in the snow. The proportion of precipitation received as snow, that is the ratio of snowfall received in water equivalent to total precipitation. Basically we measure the snowfall in water equivalent. So what happens, let us see if this is a mountain, and here the climatic condition supports the snowfall, right, the solid precipitation, right. So this is the line from where you are having the solid precipitation, right. Now what happens, first few years, let us say in winter it got accumulated maybe 1 meter, then comes the summer season, and then again you have the accumulation, so the melting was less, right. So after winter, summer season will come, and maybe because of the temperature change there will be some melting. So, initially it was accumulation was 1 meter, but there is a melting of 30 centimeter, right. So, 1 meter minus 30 centimeter, that will be your mass change or the mass balance of this particular area, right. So, this is how slowly this gets accumulated, and because of the temperature pressure they get metamorphosed and they come up with this kind of glacier ice. The annual snow budget is greatly influenced by solar radiation, because if you see, the solar radiation is the only source from where we are getting the energy to melt these glaciers, right. So, the geographic location plays very critical role here, whether this region will have high temperature or low temperature, that will be decided by the location. Then distance to ocean will also have a role that will decide or that will have influence on the total or high amount of precipitation, right. So, whether this particular area will receive high solid precipitation, low solid precipitation, that will be defined by the distance from the ocean. Then comes the topography, which plays important role on the regional scale, right. So, in the regional scale, the topography has very good impact on the glacier system. So, now we have learned what is the glacier system, what are their environment, what are the controlling factor. Now, let us learn about the ablation and accumulation. So, accumulation, we know the solid precipitation is more and that get deposited on this surface, and we say this is accumulation, right. But what is ablation? It is simply the melting, right. So, the accumulation takes place throughout the winter, tailing off towards summer. In the summer, what will happen? Then melting will start. So, the accumulation can be seen largely in winter season. Ablation is concentrated largely in the summer period, although limited ablation may occur sporadically throughout the winter if temperature happens to rise over 0. The balance year of a glacier, this is very important. The positive winter balance and the negative summer balance are combined to produce the annual mass balance. So, as I said, if you draw the graph, let us say this is the solid precipitation, right. Here it is in meter water equivalent, right, and this is, let us say this is 1 meter. Now, in the this is winter. In summer, again let us put this summer here. So, in summer it is melting, right. So, this will be the, for winter it is accumulation, for winter it is melting or ablation. So, if you see, the melting is this much only. So, definitely this has positive mass balance, right. So, this is what here we have this graph. So, if you see this kind of behavior where ablation and accumulation both are equal to each other, then we call it mass balance or the balance year. If the ablation and accumulation both are equal in a given year, then we call it balance year. So, this is winter balance, this is summer balance. Together there is no change in the mass, right. So, that is why we are calling it balance year. If the area under both accumulation and ablation curve is equal, then the budget is balanced and the glacier is in equilibrium. If accumulation is in excess, then the glacier has a positive budget and is growing. This is what we discussed in the previous slide. If the budget is negative, that means melting is more than the accumulation, then the glacier is shrinking. Accumulation is greater at higher altitude, because if you see the accumulation, the solid precipitation, it always on the higher altitude, right, where ablation processes are more limited due to lower temperature. So, here because of the low temperature, accumulation will be more compared to the ablation or the melting. That is why you can see the accumulation is greatly at higher altitude. Ablation dominates over accumulation in the lower part of the glacier. So, here when it is coming to the low lying areas or relatively at lower altitude, there the ablation will dominate than the accumulation. The point at which ablation and accumulation are balanced is the equilibrium line. So, there will be a line where both are equal to each other, that will be your equilibrium line. Let us see the different features of glaciers. So, here you have accumulation zone. So, here you can see the accumulation zones are basically at the higher altitude. The area above the equilibrium where total snow accumulation exceeds ablation is known as the accumulation zone, right. Then we have equilibrium line. The equilibrium line is the boundary that divides the glacier surface, accumulation and ablation zone, right. So, if you see, this is the ablation area and there will be some accumulation area. So, if this line divides these two zones, we will call it equilibrium line. Ablation zone, the zone below the equilibrium line where total ablation is higher than the accumulation. The ablation zone is mainly covered by the debris. Then we have snout. This is the mouth of the glacier. The lowest point of a glacier known as its terminus or toe, where the ice mass end. So, if you see here, this may be the snout of this glacier, right. From there it will start melting. So, here you can see clearly the snouts are marked. So, here if you see, in 1780 the Gangotri glacier has the snout up to this location, right. Then in 1935 this got shrunk and it is here. Then in 1956 we have this snout. Then in 1964 it is here, 1971 this is here, then in 2001 it is currently here, right. And maybe in 2025, I do not have the actual data, but probably it is again shrinking. So, you can see how the snouts are getting changed with time because of the change in the climatic condition. So, one of the important aspect of this melting is to generate or to develop a new glacier system. So, here you see this particular glacier, right, and here at the toe of this we have this glacier lake, right. So, slowly what will happen if there is more input, right. So, melting will be more. So, there will be negative mass balance, right, negative balance. So, here the water will rise and then probably because of the capability of this particular lake, the excess amount of water will get breached and it will go in the downstream. So, that is why this glacier lakes are very, very important, and we need to have very good understanding about the mass balance and development of any new glacial lakes. So, here you can see this is beautifully showing the development of a glacial lake here. Slowly at the depression just next to the snout, there is a accumulation of water, and what will happen in future, suppose if it is shrinking further, this area will also be available for this glacial lake, right. So, because of this reason there will be a new development of glacial lake and slowly this might be taking this kind of form, right. So, here you can see some of the glaciers. So, a rock and ice avalanche struck the glacial lake at the base in the eastern Nepal, triggering a 5-meter surge that overtopped the natural dam. So, because of that there was a overtopping and this extra water that caused the glow-off, right. Then here you can see the lake surrounded by steep slope below the glacier that feed the lake and threaten it with flood and avalanches, right. So, such glacial lakes are very important to study and continuous monitoring. So, here you can see the basics of glacial lakes, how they are getting generated, what is their importance. So, a glacial lake is a body of water with origin from glacier activity. They are formed when a glacier erodes the land and then melts, filling the depression created by the glacier. As we discussed in the previous slide, this depression was taken by the melt water. Glacial lakes are often dammed by moraine or ice. So, here you will see the moraines are accumulated, which is storing this water. In the Indian Himalayan region, most glacial lakes are formed due to retreating glacier as a result of climate change. Over 5,000 glacial lakes have been identified in the Indian Himalayan region, primarily in Sikkim, Himachal Pradesh, Uttarakhand and Jammu and Kashmir. The majority are located in the upper reaches of river basins such as the Indus, Ganga and Brahmaputra. This is from the ICI MOD report of 2011, and here you can see clearly we have marked the accumulation zone and these are the ridges, right, and this is where the melting is starting. So, this is what we are calling the ablation zone. This is the lake, right. I hope all the components are clear to you. Here also you can see the glaciers are coming and this is the snout, and then further we have the formation of glacial lakes, right. So, accumulation of glacier meltwater behind ice dams, bedrock barriers or moraines to prevent the water's natural flow. This is what we are calling glacial lakes. So, the moraine dam lakes formed when the glacier debris creates a natural dam which obstruct the flow of meltwater, and then there will be a formation of glacial lake. Then we have ice dam lake, results due to the temporary blocking of a rover impounding meltwater by the glaciers. Then we have glacier erosion lake, formed by the depression caused by erosion as glacier sculpt. Other glacial lakes fed by direct melting of glacier within the glaciated valleys. So, we have different types of glacial lakes and there are different types of moraine present, and depending upon that the stability will be defined. So, here you can see this particular figure shows the setting of the ice dam lake growth, right. So, here you have supraglacial lakes, then marginal lake, and because of the retreating you have the formation of new lakes here, right. And then if this is connected to a river system, these will be snow melt fed rivers, right. Failures of moraine dam, that is because of two major reasons: overtopping and erosion, and then piping due to seepage and the dam integrity. So, here this particular figure explains beautifully what happens if there is a calving effect here in this particular lake. So, what will happen if this particular mass comes to this particular system, then because of that there will be a seiche wave generation, and this is causing the overtopping, and this water may or may not remove this moraine, right, and because of this water there will be Gloff event in the downstream. If you see the breach incision, when the flowing water erodes a moraine channel, a positive feedback loop is created. This is when a breach incision occur. If you see, this particular location is the moraine breach location, right, and here we have the glaciers which is feeding this particular glacier lake. The increased water flow accelerates erosion, thereby causing failure of the dam. The process can then lead to rapid moraine dammed lake drainage and potential Gloff. Because of this, it may cause the Gloff event in the downstream. This particular image was created by NASA. So, here you can see the bishop glacial lake of Canada, how it is growing with time. So, you see this particular time frame. So, starting from 1984, how this is changing with time. Then we have South Lanak glacial lake from India. So, if you see here, this is 1967, how the lake was there, and if you see the latest 2022 image, there is a drastic change in the area, right. So, we have also created a video here. You can see this particular video, how it is changing with time, right. So, recently we had a GLOF event in the South Lanak glacial lake, and here it was having the calving effect, and because of this calving there was a overtopping of the water, and that caused the glacial lake outburst flood in the downstream. So, importance of glacial lake, now I hope you have understood the importance, but to summarize it, it is the fresh water source. Then we have a very good climate change indicator. It also attract the tourism and improve the livelihood of that particular area, and it has also very good role in the ecological balance. Then we have potential for the hydroelectric power. Then the disaster risk, that is one of the thing that we are more worried, because this can affect the lives and property of the people who are living in that particular region or in the downstream. So, if you see the water which is coming from the melt, right. So, basically it is causing the mass balance change. If there is a negative mass balance, you have more water in the glacial lakes, and then you have more vulnerability to GLOF event. So, the annual mass balance is the difference between the snow accumulation during winter and ablation during summer over a year. Thus, the glacial health can be measured with the mass balance. Glaciers are affected by the variation in temperature and snowfall. This is what we discussed. The study of mass balance serves as the system accounting for the loss or gain of ice and snow in response to climatic change. So, here this figure shows the Himalayan region showing in different color, and the glacier boundaries are shown in the purple color, right. So, if we talk about the glacier mass balance, here you can see you have two things, accumulation and melting. This is basically ablation. So, if there is an increase in the mass balance, right, then it is positive. If it is decreased in the mass balance, then it is negative mass balance. So, till now I hope you have understood, if you have negative mass balance, you have more supply to the glacial lakes, and you have more vulnerability to the GLOF kind of disaster. So, here you can see this is the mass balance that we can calculate. So, here the higher altitude, it shows the accumulation dominates, then lower altitude ablation dominates, and the equilibrium line which is having the both in the equal proportion, right. So, here you can see figure A, which is showing the lapse rate, right, and the glaciers higher reaches shows greater accumulation and vice versa. So, you can see, and we will have separate discussion on the glacier mass balance. So, this is just for your information that glacier mass balance is one of the major parameter that we need to study to see the status of glacial lakes as well as the glaciers, right. So, if you see the different cryospheric hazards which are related to this glacier system, so the various events caused by the cryospheric processes can threaten human lives and affect the surrounding. The cryospheric disasters are a result of changing global climatic condition. Here you can see some of the examples I have put, right. So, if you talk about the different cryospheric hazard, so the major ones are glacial lake outburst flood, ice avalanche and landslide, then river ice jam and flooding, sea ice loss and maritime hazard, snow avalanches, permafrost degradation and slope failure, rapid glacier retreat and instability. And just to show you the impacts of the cryospheric hazard, you can see if we talk about the sea level rise, which is related to the mass balance of the glacier system. So, from the NASA, this report was published, and you can see starting from 1990s till date, there is a change of 100 millimeter in the sea height, right. So, this was very evident from the satellite image studies. Then we have glacier surges. You can see the surges can impact the downstream. Then rock, snow or ice avalanche. So, these are the major problem in the high altitude. Then seasonal flood due to snow melt. Then glacial lake outburst flood. Then we have debris flow. You can see in the downstream how devastating it could be if you have sudden release of water. Mass wasting due to permafrost degradation. So, there are several studies which are available which talk about the mass wasting due to permafrost degradation. Then we have snow or glacier melt. So, particularly this glacial lake outburst flood is very dangerous, and these incidences have increased in the past few decades. So, we will talk about these in the next part of this lecture. Thank you very much.